version written down.
So should we like write it down or should we like take pictures of it?
It's up to you. I think you should write it down. I think what you write down goes through your head better and makes you learn it better. Taking pictures, a lot of students do it and they generally don't do as well. That's just a general rule of thumb.
Wait.
This is the lecture I got my job at COS with.
Oh, this isn't the notes?
This is the notes.
Oh, this is the notes.
This is the notes. This is the notes for 10.1.
These notes have history.
These notes have history. These notes are what got me my full-time job.
Nice. How many slides are there?
Now, I did this in my lecture. I made a small wager with the people in the lecture. And if I had prepped correctly and I had them in the house, I checked this morning and I didn't, I would have done this with you. I would shuffle a deck of cards and I'd let you draw 6 cards from the deck. I'd pick 6 people in here, you can draw a card. If you draw a black card, you get 2 extra credit points. If you draw a red card, I'm adding more problems on the final.
Yeah.
I always have fucking takers because you know what? This is actually a good thing. Believe it or not, the extra credit is an obvious one. Every student's like, fuck yeah. What you don't think about is the extra problems. By only having 10 problems on the final, each one's worth about 10%. If I had 20 problems on the final, each one's only worth 5%. If I had 50 problems on the final, each one's only worth 2%. Which means you could fuck up 5 problems out of 50 and still get an A. And on the 10 question test like you have taken, you can fuck up 1 and still get an A. So, like more questions just means less damage from individual questions. And it's not like I can give you like shit I haven't taught you. So like, it's a win-win. So I would go through this, and I did this during my interview. I let them draw, and I let them draw, and I let them draw. And guess what they drew every single fucking time?
Red cards.
They drew red cards. So, they drew 6 red cards in a row. If I'd done it in here, it'd be 6. I'll tell you what, I'd let students just keep fucking drawing. Oh, you want to go further? I don't click on this slide yet. I just do the shuffle, like unseal a pack of cards right in front of them. Unseal a pack right in front of them. Shuffle it right in front of them. Walk around. They keep getting bad cards. Like, I'll tell you what, I'll start leaving those cards out. So like there's less red cards in the deck. So your odds of getting a black go up. We learned that in chapter 5, right? Well, if the entire deck is all fucking red, you have no chance of getting a black card. And the easiest way to do that is you don't unwrap the fucking deck of cards, you just cut out the bottom of 2 decks and you make a solid black deck and you make a solid red deck. So I did that with my lecture. I do this with students all the time. I've had them fucking pick like 18, fucking 20 cards. Just keep going, and they're like, generally I get bullshit, called bullshit, like a cheater, within 3 or 4 cards. Which is actually normal. If something happens where you think it should be fair, 50% of the time, and you get 4 or 5 in a row, you start that are against you, you start going, this is suspicious. If you get 4 or 5 in a row in your favor, you're like, fuck yeah, this is awesome. No questions asked. But if it's against you, you're like, this is some bullshit. So you drew 6 red cards in a row, and we did this probability shit. Drawing a red card plus a red card plus a red card. They're all independent events. I can multiply them out. The probability each one is half. And so 1/2 to the 6th power is about 1.6%. The probability of drawing 6 red cards in a row, if we put the card back in the deck, is about 1.6%. Now the question is the teacher a hustler or are you just unlucky?
Yes.
I already told you I was a hustler. I fucking stacked the deck. This is the idea of the hypothesis test. This is the very premise of the hypothesis test. We made an assumption about reality. Y'all are right. Maybe I'll fucking slow my shit down. I'm sure it's on the next slide anyways. How does a baby kick hard enough on the inside to bruise the outside? That fucking it's mind blowing to me. This was Sarah told me she got a bruise on her side. And I was like, you're pregnant? She's like, are you fucking blind? You're just stupid. She didn't say that. I'm waiting for the day Stu fucking says that shit. All right, you guys ready for more?
We go back.
Fucking just get up and slap the goddamn shit out of you.
You go back to the first one.
I would write down the main points here. If you want to write down everything, I'll load this PowerPoint for you. That way you're not wasting time writing a fucking story.
Okay.
Did you get what you needed from this page, John Luca?
This one.
Fucking turkey bacon.
Eating, right? It's good.
Did your dad say that too?
No, my mom. She was cause she when I was like growing up, she did bodybuilding, so she mainly.
What the fuck? I've heard of female bodybuilders and I've seen female bodybuilder pictures, but I've never known a female bodybuilder. That's fucking crazy. So your mom can beat your dad's ass pretty easy, is what I'm hearing. No, he's bigger?
No, now, but he was too back then. He worked out with her, but he didn't do bodybuilding because he did general contracting. He was like too busy with that. She was just like she was.
We need to do a fucking case study on John Lucas' family. Because this is a whole fucking story here to unpack. All right, so we got through this. And so what that 1.6% means is if we did it 1,000 times, you do 6 cards, putting the card back, you could expect to see 6 cards, red cards in a row, maybe 16 times out of 1,000, which is highly unlikely. Remember, anything less than 5% we call unusual. 1.6% is really unusual. So outcome A was I got lucky, or rather you got unlucky. You all drew bad cards, or you didn't have a chance. The deck was stacked against you. I'm so sad I even have a double-headed coin. That I know where it is at home. I didn't think to fucking look for it until I was at work this morning, because I would have brought that in and like, let's flip the fucking coin. It's the same thing. And I would have let you pick. Clearly, I would have said, I'm heads, you're tails. And we would have fucking flipped that coin and would make it land on this thing fucking as many times as you guys want me to flip it, it'll land fucking heads every time. Because both sides are heads. It's a trick quarter. So, this is the heart of hypothesis testing. What we do when we do hypothesis testing is we make an assumption about the world around us, about reality. the assumption made by, well, the North students normally, you guys didn't ever get the chance. But the assumption was that the deck was a brand new deck, it was fair, there was half black and half red cards. Then, in a hypothesis test, we gather sample evidence and analyze the results, see if it contradicts our assumption. That's what we're doing. We have an assumption about reality, and then we gather evidence to see if our assumption is wrong.
Is that BL or BI?
BL, probability of black. You know, it was a bucket slide. I don't know why I didn't just type in black. I could have spelled out black. You know?
Yeah.
Oh, it got me the job. That's all that matters. So in our example, we drew 6 cards. We gathered evidence. You didn't think of it as gathering evidence. I miss a slide? No. Okay, so that's how hypothesis testing works. We know the outcome here. We found that the evidence was against it. 1.6% of making that happen is unlikely. So,
Are we, can I see that last equation? That's just trying to score.
so a hypothesis, what is it? I'm calling it hypothesis testing. What the fuck's the hypothesis? It's a statement about a characteristic of one or more populations. And we will focus on a single population parameter each time. Kind of feel like maybe I should write this out. Not for you guys, but for me. Because like for me, I'm like, oh my God, this is taking forever. But I know if I was writing it out, it'd be just as long as it's taking you guys. In my head, I'm just sitting here idly watching you guys. This was not well thought out. All right. So we're gonna focus on like parameters. Parameters are like the equivalent of sample statistics. Statistics is the things we get about a sample. Parameters is the same thing about population, like our mean, our standard deviation, shit like that. Proportion. Those are examples of parameters when we're talking about populations. Those are the things we're going to look at. So here's an example that's related to dairy in California. This is real shit. I pulled it from the Department of Food and Agriculture. The percentage of milk fat in California dairy milk in 2012 was 3.72%. Researchers believe that a change in diet has changed the percentage of milk fat content. What parameter are we talking about here? And what claim is the researcher making? After you guys are done writing it down, we're gonna discuss it. So what parameter are we talking about? Like, think of the things we've seen in the class. We've seen mean, we've seen standard deviation, we've seen variance, we've seen proportion. What kind of parameter is this? What do we normally associate percentages with? Proportions, right? This is a proportion, it's about the proportion of milk fat. What are the researchers claiming?
There's a change in milk.
What does that mean? What's a change mean? You're right, but what do you think that means? What does a change in milk fat content mean in this case?
It's either higher milk fat or lower milk fat.
It's either gone up or it's gone down. They didn't actually say which way. Sometimes you won't know. You're just saying it's not the same anymore. This is an example of not the same. Yeah, that's correct. We're talking about proportion and like it's changed. Here's another one related to agriculture. For every inch increase in standard deviation of plant-to-plant spacing, the corn grain yield rate drops approximately 2.2 bushels per acre. A new corn planting machine revealed at the World Ag Expo claims it has decreased the standard deviation below that of its former model, which had a standard deviation of 4.5. What parameter is this statement about, and what is the claim? This was based on a study by Purdue University. The whole World Ag Expo thing, I made that shit up, but the actual 2.2 bushels per acre thing, that's real.
I'm still kind of confused on the claim for the last.
The claim was that the proportion was no longer the same. Or the proportion was not 3.72. We're gonna have this slide come up again. We'll actually use numbers in a second. I'm just making sure we know how to identify parameters and like what they're really saying.
Wait, what was the parameter for the last one?
The parameter for the last one was proportion. And that it had changed, up or down, unclear. See folks still writing. What parameter are we talking about here? Remember, parameter looks like a statistic thingy.
Bushels per acre.
Bushels per acre, well, what is that? Are we talking about like, what is that in terms of statistics? Like a mean, a standard deviation, a proportion? Are we looking at variance? Like, what are they claiming is changing?
Standard deviation is changing.
They're claiming the standard deviation is changing. So we're talking about standard deviation here. What are they saying about it?
Drops.
Decreased is drops, right? So they're saying the standard deviation is actually lower than the 4.5. Or standard deviation is less than 4.5.
So the parameter would be the standard deviation,
Yes,
and so,
and the claim is that it's gone down.
okay.
I think in the future, maybe they should reorganize these slides and put the ones with the numbers right after it.
What's the parameter?
Standard deviation.
4.5 inches.
Well, the parameter is standard deviation. Its old value, the assumed value is 4.5. The claim is that it's going down. And we'll look at a third one. The average final exam score for stat students was 73%. We believe the use of computers in statistics courses has increased the average grade of students receive on their finals. That's the scenario. So what parameter are we talking about here? Mean. It doesn't actually say mean, but it says average. And we know mean and average are the same thing. So here we're talking about the mean. That's the parameter, population parameter, we're talking about mean. What is the claim that we're making?
Increased the average grade students receive on their final.
So what does that mean in terms of the mean value of 73%?
It goes up.
It's gone higher. The mean's actually greater than 73%.
Are these the kind of questions that are gonna be on the final?
What?
Are these the kind of questions that are gonna be on the final?
No. Questions on the final would be far worse.
Great.
It will make you tremble in your boots, or your sandals, or your moo-moo. You may not like this right now because you're not used to this type of question. You're gonna get used to this type of question real quickly. It's like trying turkey bacon for the first time. You're like, what the fuck is this garbage? And then after you eat it for a little while and you stop trying to call it bacon, you're like, this isn't a bad meat product. Meat product. Did you hear the words there? Meat product. There's nothing bacon about it. And you get used to it, and then you're like, okay, it's not bad. All right. So hypothesis testing is a procedure that we're going to use. We use probability, we're going to have sample evidence, and we've got two competing hypotheses about a characteristic or parameter of one of our populations. The null hypothesis, which goes by H sub 0 or H naught, that's the one we assume to be true. That's like the old info. What was true before? It indicates that there's nothing changing. It's the status quo. Like the milk fat's still 3.72%. The mean grade is 73%. H naught is the pre-existing information. And it's a statement of equality. You're gonna see an equal sign in it. If you have H naught where it doesn't have an equal sign, you're doing something wrong. You will hear me say H naught or null hypothesis when we're talking about this. Naught means 0, so that like H sub 0 is H naught. Now I know why I didn't put the other slides with the numbers first. I had to talk about what the null hypothesis is and the alternate hypothesis is before I put that shit down. There's no point in it. we will do 10.1, the section we're doing, which is the slides. And then we'll do 10.2. We'll save 10.3 for tomorrow. 10. Like everything from here on goes a lot quicker. After we get to the slideshow, all the sections are shorter.
How many slides is this?
That's an excellent question. It's more.
More? Okay.
All right, everyone ready? So the null hypothesis goes by H naught. We're also going to have the alternative hypothesis. This is the competing claim. It's the new one. It's the one like, what are the researchers claiming? What do teachers are claiming about the mean scores? And it goes by HA, A for alternate hypothesis. It also goes by H sub 1, which I didn't put down here. Depending on which book you look in, it'll say HA like that, or it'll have an H1, or the 1 is in the same spot as the HA.
They mean the same thing though?
They're the same thing, yeah. I mean, you can think about like HO for original and HA for alternate. Or you can think about them as H0 and H1, which is like, I think I like the original and alternate better myself. That's why I put HA here. Now, this is a statement of inequality. We're gonna have a less than sign, we're gonna have a greater than sign, or not equal. If we don't know if it's less than or greater than, we've just gotta say not equal. This is gonna be a boring video. I'm not talking all the time. Okay, everyone good? Okay, so our first one we did was the milk fat one. And we said the proportion was 0.3 or 3.72%, and the new claim was it's not. How this relates to alternate or the hypothesis is H naught is P equals that 0.0372. And HA, the alternate hypothesis, is P does not equal 0.0372. This is called a two-tailed test. This is why your teachers that do nothing but slideshows like this, they always go too fucking fast. Cause they're sitting up there idly doing nothing and going, God damn, this is a long silence. Silence gets uncomfortable after a little while. Unless you're like with your like spouse, your boyfriend, girlfriend, after like the first like the ooh, everything's fucking fantastic, you get to that nice comfortable silence. Like you just sit next to each other for an hour and a half and not say a goddamn thing to each other, and you'll be fine. In a classroom though, it's fucking uncomfortable. You feel the need to talk, which is distracting. All right, I just gotta be patient. So the next one we talked about was the corneal and how the machine said it was gonna be able to lower standard deviation. So again, H naught is a statement of equality. There's an equal sign in it. The standard deviation, sigma, equals the 4.5 inches. And the alternate claim, which is the new claim, was sigma was less than 4.5 inches. This is called a left-tailed test. The easiest way to remember is that inequality symbol points to the left. Just flat out. This is the easy way to remember it. It looks like the arrowhead on the pointing left. Right?
Yes. Did that change?
Yeah. That was the old one. This is the new one. Different values, different problem. This was on the corneal. I want to say we're about 2/3 of the way through the slides. In these slides, we're talking about different forms of the null hypothesis and the alternate hypothesis. Then we'll talk about how do we test that claim? Fucking black hair, dark hair is fucking with me, Mateo. Totally fucking with me. Isn't it? I bet.
Yeah, I'm used to seeing it blonde. I was like,
Long test.
I noticed it quickly.
John, he went home and he mouthed off to his mom, she slapped the blonde right off. Oh shit, maybe that's John Luca's mom. He went over to John Luca's mom and she got that fucking bodybuilder backhand going on. Whoosh. Fucking cleaned as shit. Blonde flew right off.
We used to do that with his mom. So it's funny. That's crazy how they train.
Yeah. Bodybuilders, that's some dedication shit right there.
And she literally would just have like Tupperwares of like just chicken, broccoli, and sometimes rice. And then just
Yeah,
big
just a
chunk
little bit of
water.
carb, but veggies and.
Yeah.
Did she still bodybuild?
No, not in New York. She got too busy, but like,
Did she still like exercise a shitload, but not
yeah, well, we
bodybuild?
have like a gym in our garage now, so but she used to like when she prepped for her shows. It was so fun. Just all not her fun. It was kind of like you can only drink like a big jug of water. You can't eat anything, and then
Why?
And you need all the muscle you can get, to show off.
yeah,
Well, how does eating meat or something like that hurt your muscle content?
As you eat something.
You gotta weigh in though, don't you?
Yeah.
I imagine it's for weigh-in purposes.
I think so, I don't know, but I forgot what the reason was, she explained it to me.
Also before their shows, they don't drink water to drop the water, to lower the water content in your body. One of my friends is like doing her second show next week.
I don't know, to me, most bodybuilders go too far. They're like, you are like, it's completely unappealing to look at.
Oh, when they get like super huge.
Yeah, like you shouldn't just be a walking muscle.
It was funny, because afterwards,
You know what I mean? Male or female, it doesn't work for either.
like, we would go to, you know in Fresno, that restaurant BJ's? She just get a big old, like, you know those like pizza cookies?
Bazookies.
She just,
That's funny. All
Probably not a star.
she would feast.
right, next slide. Next slide is the right tail test. This was on the mean being 73 or the mean being high. And just like the greater symbol looks like an arrow pointing to the right, this is a right tail test. Where's my dog? Where is he?
Or
You know,
The fuck did I call him?
your dog.
Jazz.
What? Jazz. It was Jazz, right? Yeah. Fuck
I
is
think he'll come
Jazz.
tomorrow.
What?
I think he might come tomorrow.
Hopefully he's, I haven't even checked to see if he's been doing his homework. We'll find out. Not my grade, I already passed. I got my degree, I make good money. It's worth the work.
It's Mew, right?
Yeah, that's mu, not you, but a mu. You know how fun it is to find Greek symbols, put them in this shit? Like you open up Word and look for alternate characters, it gives you like fucking like 80 different languages. You know, like 60 symbols in each fucking language. You're like scrolling for days. You're like, I don't know what fucking Cyrillic, Hellenic, what the fuck? It doesn't just say Greek. It's got like some fucking different names. Looking for the one you want. Yeah, this was fun. Everyone good? Nope, John Lucas is still right. All right. So, we're doing our hypothesis test. We have our two claims, H0 and HA. What do they mean? Well, the null hypothesis is a lot like saying not guilty in a court of law. It's something we assume to be true until proven otherwise. We assume not guilty. The alternate hypothesis is much like guilty. Now, there are two actual outcomes. There's only two ways it's true. There's only two ways that the true situation of it, like a crime, is they're either innocent or they're guilty. But the verdicts are never innocent or guilty, are they? We've all at least seen one fucking TV show with crime in it, like a court of law. It's always guilty or not guilty. Why? Why is there a difference? Why don't we say innocent? Why don't we say innocent or guilty? We don't. There's a reason. And the reason being, I'm sure I say it on the next slide, but I'll say it here. Just like in statistics, we can gather as much evidence as we want, and we can think the thing as a person is innocent all we want, but it doesn't mean they actually are. They might actually be guilty. So the verdict is never that they're innocent. They just haven't been convicted of being guilty.
Is that the reason why it's referred to as the accused?
You're accused of doing a crime.
Would innocent also be like true, like in this case?
What?
Would innocent be true in this case for the?
Yeah. Kind of. H-naught is like the original claim is true. The equal portion is true. HA is like saying the equal portion is not true. I'm certain John Luca fucks with me in this class. Like 70% of the time he's the last one writing, but sometimes, probably 80%, sometimes his pen goes down first, or not first, but there's people still writing. I'm like, is this motherfucker just drawing Roadrunner or Donald Duck on his shit while I fucking think he's writing shit down? And all of a sudden he gets tired of drawing the fucking, Wile E. Coyote. All right. So I was just talking about this. We say guilty or not guilty. They're never declared innocent. We can provide strong evidence that the null hypothesis is true. But we're always basing our information on sample data. If we ever have the entire population's data, we're not doing hypothesis testing. That's the difference. If you have the entire population's data, it's not a fucking guess anymore. It's one way or the other, fact or fiction. But since it's not, since it's based on a sample,
Would this be at the?
I will have this in Canvas, if that's what you're asking. That's what it is. He got tired of writing. That's fine. That's all good. A lot of this stuff is more understanding. If only you understand this part. Like being able to write down the way the different H-naughts and HAs are, the last few slides, that was pretty important. Here, this is a conceptual idea. As long as you get the fact that sample data, it's just a sample, and we might very well just have a bad sample. Like, I might be asking about average intelligences, and I fucking get all the fucking Mensa members on campus to fucking, answer the survey and no one else. And now all of a sudden it looks like the average intelligence of a COS student is fucking 130. And there's no way in God's hell that's possible. But the sample evidence would indicate so. So it doesn't mean the average intelligence is 130. It just means that sample set. Same with court of law. The evidence may look like they're innocent, but it doesn't really mean they are. It just means you didn't prove it. You gotta have a really good criminal mind to get away with some shit like that. A lady I work with at the diocese when I did accounting, every day, not maybe every day, every week, she came in telling me a new way of how she wasn't gonna kill me. and dispose of my body. She settled on a fucking lime pit. The lime pit dissolves all flesh, fucking bones, tissue, teeth. It gets rid of everything. It just takes a while. That's how she was going to dispose of my body. She was like an older sister that liked to threaten me. Fucking, I drove her crazy. She was in the cubicle next to mine. Oh yeah. She passed away 2 years ago. I miss her. She was a lot of fun. I loved giving her hell. That was terrible. I was like 24, and I'm working with a bunch of fucking 45-year-olds. What do you think's gonna happen? They're like older sisters. I was the only guy, you know. All right. Nope, someone's ready. I gotta wait. Be patient. Try not to be that fucking asshole teacher that I didn't like, that fucking raced through slideshows way too fucking fast. Like, I can't even keep up with what you're saying. I can't read that fast. So I gotta make sure we get there. Okay, so we have two outcomes. The equivalent of what we're doing here is we can either reject the null hypothesis or we can fail to reject the null hypothesis. Rejecting the null hypothesis is like, if the null hypothesis is true, it would surprise us based on the fucking evidence we have. It would surprise us based on the data we have. When this happens, there's usually sufficient evidence to reject the null hypothesis. We say these results are statistically significant. That's a phrase they like to use. I don't use it, but when you see statistically significant, and we will always make our final verdict on the hypothesis testing as there is sufficient evidence to support the claim, and you'll see how that sentence finishes as we get into 10.2. The null hypothesis for the deck of cards was that it was a fair deck of cards, that half the deck was red and half the deck was black. That's what we assumed to be true. It took a lot of evidence, and when we got like all red cards, where like this can only happen 1.6% of the time, if that was a fair deck, it would surprise you. Generally, you don't even need to go to 6. Like 5 is usually what triggers people. 5 is when we can start getting like into really like below 5%. And then failing to reject the null hypothesis, if it is true, it's not really surprising. This would be like if we drew 3 black cards and 3 red cards. So like in this scenario, let's say you guys wanted black cards. John Luca drew 3 red cards in a row. He immediately called bullshit on me. He said the deck is stacked. He has now made an alternate claim that the deck is not fair. And then we happen to get 3 more black cards, and like all of a sudden that alternate claim isn't looking very good. There's not really any evidence to support the claim that I cheated. That would be something in the fail to reject the null hypothesis. In this case, we're going to say there's insufficient evidence to support the claim that, and this claim, the claim we're talking about in these sentences is always about the alternate hypothesis, as you see when we start 10.2. I think I want to switch over to the camera real quick and add a little more to this. I'll switch right back in a second. The reject the null hypothesis. You will hear me say reject H naught, That's the null hypothesis, support HA. The other one says fail to reject H naught. Or fail to reject the null hypothesis was the wording on it. The way that's easiest for students generally to remember this is do not reject H naught. Do not support HA. And there is not enough evidence to support the claim. This is pretty clinch right here. Here there is enough, there is evidence to support. But this fail to reject null hypothesis, this little part right here, we have a not right here, do not reject H naught, do not support HA, and there is not enough evidence. The nots go together. That's the easiest way to remember the outcomes of the hypothesis test. That's too much red. I should have changed colors up somewhere in there. There's another one for you, Mateo. You like this. See, I can say it to you because you know I ain't damn well blowing your kids. I can't say that to a girl student because now all of a sudden it sounds like I'm sexually harassing them. Right? I don't want to get in trouble for harassment. But with you, if I get in trouble for harassment, it's gonna be me saying that your mom fucking failed you and told you to take a class you didn't need. That's not really harassment. That's just gonna be me getting my ass beat by your mom. Well, John Lucas' mom. You better pass this class, John Lucas, because I don't want your mama showing up trying to kick my ass. That's fucking embarrassing.
That's up to you, man.
That's not up to me. That's up to you. I'm not passing you. I'm not gonna give you a passing grade if you don't earn it. There's no charity here. This isn't Goodwill. It's not the Salvation Army. If you pass this class, you will go, I earned this grade. You will feel good about yourself when you do.
That's all I'm trying to.
We'll get there. All right, that's the rest of that slide if you guys want more. But I really thought I needed to get the not down. I think we got a couple more slides. I think we're almost done with the slides. You guys ready for more? These are the errors we can make. We can be wrong. We just won't know it. We can reject the null hypothesis when it's true. This is called a type 1 error. This is like convicting an innocent person. This is the mistake we want to avoid. We would rather let a guilty person walk free than make an innocent person suffer the consequences of something they didn't do. So we err on the side of not making this mistake. And it happens when the sample evidence just doesn't provide enough evidence to reject the null hypothesis, but it should have. Like, it's just a bad sample. The other type of mistake is rejecting the null, or failing to reject the null hypothesis when we should have. This is like letting the guilty walk free. This would be like you guys saying, no, we drew 10 red cards in a row. You know, there's a lot of evidence that Jones fucking cheated us, but I trust Jones. He hasn't led me astray yet. I don't think there was anything wrong with that deck. That would be you failing to reject the null hypothesis that the deck was stacked, and you should have. I think there's a question in the homework about type 1, type 2 errors. So type 1 error is rejecting the null hypothesis when it's true. Rejecting H naught even though you shouldn't have.
Erroneous outcomes are those like.
Like when hypothesis testing fails us and we don't know it. You won't know that this has happened.
So what will this like on any test, like in the finals or like in the.
This.
It'll just be like a word problem that we have to like pick at it.
No, this is not something you will ever be able to identify on your own. We will never know that this is true. Unless we just gathered more evidence and found out we were fucked. We did it. This is like, you know what? I asked fucking 40 students and I found the average IQ was 130. That smells, fucking fishy to me. I'm gonna ask another 100 students, and all of a sudden I get the average IQ is around 100. And I go, okay, maybe the other one was wrong. But generally, there's no reason to question it unless it's like just too far out of the fucking ordinary.
So what would it look like on a question like for this whole like for chapter 10 like, well like have we already done it yet or no?
What do you mean?
Like the question like kind of like it would be in chapter 10 homework I guess.
You'll see it when you get it. It'll ask you what's type 1 error is. It'll just ask you, what does it mean? It means you rejected the null when you shouldn't have. The null hypothesis was true, like the deck was fair, but you rejected it anyways. This would have been drawing 6 red cards and I'd actually used a regular deck. It was just bad luck. Unless I show you the deck, you don't know that it's wrong. You gotta go with what your gut tells you, what the fucking math shows you. You gotta go with what the numbers show you, but you're not gonna know if this happens. You won't know. That's what people don't like about statistics. It can produce wrong shit.
So on the final, will it be like,
You will not have a question on the final related to type 1 or type 2 errors.
okay, will like, for the final, would they be like, the questions, will they be somewhat similar to what we're doing in our homework?
They're going to be somewhat similar to what we're about to start in 10.2. 8 of the 10 questions will be like what we're starting in like 10 minutes. So you'll see, just wait for it. All right. So the probability of making a type 1 error is, we associate with the value alpha. Alpha is what we use for our level of confidence, our level of significance. And it's the probability of rejecting H naught when H naught is true. So we will numerically quantify what chance we're wrong. But we won't ever actually really know if we're wrong. Unless you do another study. So you're gonna see this word phrase a lot, level of significance. It's alpha. We're gonna use alpha a lot. Alpha is one of our 5 steps of hypothesis testing. Pick an alpha. We get to pick alpha. Okay? If the consequences of being wrong are severe, you want to pick alpha as low as you can. The average alpha we use is 0.05. If I don't have a slide on this coming up, I will write this down on something. I'll wait to talk about this in case it doesn't have a slide. You saw that I made this slideshow like 5 years ago. I don't remember what's on it. I do it once a semester. Well, sometimes 3 times a semester, but it's all the same week. That one's for John Luca. Smells like turkey bacon. You'll love it.
Wow. That's crazy.
You know one of my favorite moves? When you let one of those go and it doesn't make a sound, and you get a little smell of it, and you're like, that shit's bad. Sometimes it doesn't, sometimes you don't smell it. Sometimes there's no smell. You're like shooting blanks. But sometimes you're like, oh my God, I want to, fucking bury my head in the pillow. You keep a straight face, and you ask the people around you, you smell something burning? That is a question that always triggers check. How do we check for burning shit? We smell for smoke. Because burning means fucking fire, and that means we could die. That's something we check for. We don't want to die. So you can get people to go, and if fucking it's spread enough, they get a nice little piece of that.
Wow.
Next time you do it at home with your fucking family, or if you've got any younger brothers or sisters, do that shit with them. You let out a silent one, it fucking smells. If it doesn't smell, you're like, that doesn't do any good. You learn more than statistics in this class. I'm a fountain of knowledge. Do you have younger brothers, John Luca? Younger sisters?
I have a little sister. I have an older brother and a little sister.
It's less fun with sisters. Although they overreact no matter what.
She's funny, but like, dude, if I fart near her, she like loses it. She's like,
It's fucking awesome. My wife loses her shit when she knows I fart in public. Like, it's fucking out of control. And she knows, because, like, my face apparently goes lax. I'll be smiling, I'll be, you know, shit like that, and all of a sudden, it's only for a second, just long enough. If we're in a restaurant, no, you didn't. Yeah. Yeah, I had to, you know, no one heard, no one's gonna smell it. What if they do? I'm like, they're not gonna know it's me,
Oh, okay.
right?
Yeah.
Not, they weren't gonna know it until you started making a fucking scene, you know? All right.
Let's look around the restaurant.
Ah, shit, that was it. Look at that, we're done. So, back to what I was saying with the alpha thing.
So you're just looking around the restaurant, who's shuffling cards?
So, alpha, this is our level of significance.
is this 10.2 or?
This is still 10.1. I'll get over it. It's related to 10.2. You need to know this for 10.2.
Sounds like a ribbon.
What?
Is it an A or like?
It's alpha. It's a Greek letter alpha.
Oh.
It does look like one of, you know, like the pink ribbon, like cancer awareness ribbons and shit like that. It looks like one of those. This is we pick a value here. The standard value is 0.05. This is the default value. Why? Because we like to say 5% chance is unusual. If the consequences of being wrong are fucking severe or important, or even dangerous, deadly, you want to use something like alpha equals 0.01 or even lower. Something low. Every once in a while, if it doesn't really matter a whole lot, you make it higher. This is like, what's the mean sales from our vending machines? As long as we're making a profit, there's not a really like severe impact of being like, the profit is $50, no, it's higher. Who gives a fuck if we're wrong? It just lowers the bottom line, it's not severe. If we're talking about heart surgery, you don't want no 5% error rate, right? I want to go into the fucking knife if there's a 5% chance of fucking dying. That's some serious shit. That kind of, you know what I mean?
What does it say, something low?
Something low, yeah. And these are related to our confidence intervals. So confidence intervals. For our two-tailed test, the percentage is 1 minus alpha times 100%. So like alpha equals 0.05 leads to a 95% confidence interval. If I do 1 minus a nickel, I have 95 cents. 95 cents times 100 is 95%.
Yeah, two-tailed test equals percent, okay. I just gotta write this when I reference it, I can understand it.
Okay. One-tailed test. Yeah, that should say 2. It doesn't look like a very good 2. One-tailed test, like the left or the right, you're better off doing 1 minus 2 alpha. So like if alpha equals 5 or 0.05, doing 1 minus 2 times alpha gives you 0.90, which would be 90%. They write it differently in like the lecture note or like the examples you see in there. And I don't really care for the way they wrote it. I like did the math on this shit, and this shit makes more sense to me. And I'm gonna hit pause. I think we need to give you guys another break. 10.2. All right, 10.2. 10.2 and the rest of this fucking class. Hypothesis testing. 5 steps. You are never gonna have a teacher you have as much fun with as you do with me. It's gonna make you sad. I've ruined the rest of fucking college for you. Everything from here on is downhill, no matter how much you like the subject. You'll be like, they're not having.
I played Clash Royale with my art teacher, and that was like the closest thing.
You play what?
Clash Royale with my art teacher.
That's pretty close.
It's pretty close, but he's an art teacher, so.
I game with students. Like the Mason Center down below, there's days, like the engineering students, they'll bring in their Switch and shit like that. I'll let you kick my ass at fucking go-kart or Mario Kart. All right, so step 1, identify the 2 claims, and label them. You will have an H0 and an HA. On the H0, you're gonna have a fucking equal sign somewhere. On HA, you might have non-equals, you might have greater than, you might have less than.
You won't have less than equal to?
No, because the equal to is up here.
Oh, okay.
The symbols on the left have to match. Or, I put sigma, but we could use mu, we could have proportion. If you're doing variance, we're not doing variance in this class, you could have variance. The symbols on the left have to match. And the numbers on the right have to match. The only difference is these symbols in the middle. That's the difference between H0 and HA. If you look back on what you wrote on from your slides, you'll see that that was the case in each of the ones we had. Symbols on the left were the same, the numbers on the right were the same. The only thing that changed is the top has an equal and the bottom one doesn't. You don't have to write them in this order. You could put H0 on bottom, but you should label it as H0 and HA. You should label the null hypothesis. Two and 3 can happen in any order. Output, different than the order I think that I have in like a handout. Identify alpha, pick your alpha. If it's not listed in the problem, alpha equals 0.05. They might not say alpha, they might say level of significance. But that means alpha.
You know that's the difference. Number symbols on the left and right are the same, except for those symbols.
These symbols are what's different between them. One's got, the top one's got an H naught has an equal. H naught has an equal, HA does not. It has a different symbol.
So H naught can never have not equal or less than greater than?
No, H naught is always gonna be an equal sign.
And same with HA.
HA is gonna be one of those three symbols. If you see it written another way, they did a fucking really poor job. Like H9 should be the, like what it was before. Now, 2 and 3 can be done in any order. 3 is find the test statistic and p-value. This is a StatCrunch operation. Except on the final, where I will tell you what they are. On the final, I will tell you the test statistic is this value, and the p-value is this value. Step 4, we will compare p-value and alpha. And I will almost always from now on say p-val, because I'm fucking lazy, too lazy to say an extra syllable. You should see some of the bullshit rules mathematicians have come up with to save a fucking single character. Like on the when you're writing it out. Like when you do, like if you do go into algebra and you're doing like composition of functions, f of g, if you actually write it out, it takes like one parenthesis symbol more to say it, the real, like what it really means. But we always fucking abbreviate it. Okay, so we're gonna compare p-value and alpha. We have two possible outcomes. Outcome A, the p-value is less than alpha. Outcome B, the p-value is greater than or equal to alpha. This is going to tell us what decision to make. And I've got a little jingle for you. You know it's good because it's a Jones jingle. If the p-val is too low, reject the hoe. That's badass. There are some teachers who will say if the p-val is too low, the null must go. Like so, if you don't want to say hoe, but hoe rhymes with low. We don't really hardly ever call it ho, it's H naught, but it looks like ho. The p-value is too low, reject the ho. What we're doing here is we reject H naught and support HA. Do you really need a jingle for the other one?
It'd be nice for consistency.
Be nice for the notes.
Can't talk that last one.
I've had one, but they're nowhere near as good. It's not coming to mind. They're right down in the other part of the fucking notes. All right, if you want consistency, if the p-value is too high, the null's no lie. That's terrible. That's some like fucking dad comment shit right there. Really, all you gotta do is remember the top one. If it doesn't meet that one, it's the other one. You know? So if the p-value is too high, if the p-value is not too low, we're not gonna reject the ho. Do not reject H naught. And we will not support HA. Am I boring you, Mateo?
No, I just finished writing down.
Immediately we're in another video. Okay, step 5. Ow, fuck. My back got pinched in the chair. That's rude. Step 5 is we're going to make a statement, state our conclusion. This is always, always, always about HA. Do we support it or not? So if we're supporting it, a nice consistent way of doing it where it never changes is there is sufficient evidence to support the claim that, and then what you're going to do is paraphrase HA here. Or if the question is worded well, you can literally just fucking strip mine it from the fucking question that you're answering. You'll see examples of this in a second. I'll show you me just fucking borderline plagiarism. I'm gonna just take the fucking sentences, I'm gonna drop off the question mark, and that's pretty much what we're gonna have. Other than this sufficient evidence business.
Is that here or there?
There is sufficient evidence that here. Support the claim that, we'll paraphrase here, and then you can optionally put with a level of significance, like if you were doing a real paper and you wanted to add it at alpha equals whatever the amount is, say what it is. B is when the p-value is too high, the null's no lie, the null is true, we're not gonna reject it. There is not enough evidence to support the claim. Or there is insufficient evidence is another way of saying it. And everything else is like literally the exact same thing as the rest of A. The only real difference you have right here between these two sentences is this right here. Those are the differences between the two answers. And you'll see when we're writing them out what I mean by this. We'll do an example. It's either sufficient or insufficient. As we are going through them, for every single hypothesis test we do, the only thing that fucking changes is H naught. Well, H naught and HA, step one changes. We have different symbols here. When we're looking at two samples, we have different things we can say, like, we'll be comparing the two samples, but really the only thing that's changing is H naught and HA. Every other thing stays the same. You need to identify alpha, you need to find your test statistic and p-value in StatCrunch, or if it's given to you, use it. You have to compare them. You have to determine what you're going to do with that information. Do we reject H naught and support HA, or do we do not reject H naught and do not support HA? And finally, we'll make a statement. We'll write like some English words, make it look like we know what the hell we're talking about. That's half the battle of looking smart, is just pretending and putting on a good show. Throwing in appropriate grammar is always helpful. But I'm not grading you on that. I'm not expecting some grammar artists in here. I better know what you're saying now.
Okay.
I've had students like do some hand wavy shit where like, your shit's all over the place. Like, you could come in and try to argue with me one way or another later on what it means, but I don't understand what you're saying looking at it, because you have like, there's sufficient, not sufficient. What? All right, so how does this work for 10.2? 10.2 is on one sample proportion test. In this scenario, H naught is P equals, and HA is P is one of the others. Does not equal, greater than, or less than some number. It is important to note that we need a normal distribution to do this testing. If it tells you that it's normally distributed, that's all you need. Problem or stuff may say that it's normally, problem may say that it is, which is good enough. If not, we had some criteria we've talked about in the last couple of days. We need to do n times p times 1 minus p, show that it's greater than or equal to 10. And we need to show that n is less than 5% of the population. Some of the homework problems will actually ask you for mu and sigma. So as a reminder, mu with p hat is just p. And sigma with p hat is that square root of p times 1 minus p over n. Just to have all the information you need in one spot. Sometimes they throw that in there and go, what's mu and what's sigma? And the way we're doing this in StatCrunch is stats, proportion stats, one sample. So let me give you an example. This occurred at the college recently. The whole pandemic, oh, John Lucas is back. That's recording. Okay. So, example. This came up during the pandemic. It is believed that less than 40% of students want face-to-face math classes. We'll say Math 21 statistics classes to be specific. They prefer online. In fall of 2021, $389 students had enrolled for face-to-face classes. And 791 online. Test the claim. That it's less than 40%. As a reminder, when we do that stats, proportion stats, one sample, StatCrunch will want X and N. So we're gonna need to be able to give it that. This is number of successes, and this is number of observations. Deciding how we're gonna label H naught might help us find out what these values are. So like maybe we should say it, H naught and HA is saying less than 40%. I should have less than 0.40 here. And that's the number that prefer face-to-face. That's the proportion. I'm gonna put F2F just to remind me that's what it's talking about. Usually what you're gonna have is information about the alternate hypothesis. You kind of gotta fill in what H naught is. If we're doing the proportion is less than 40% or 0.40, then H naught has gotta be P equals 0.40. And P is X over N. So if we're talking about face-to-face, X should be the number of face-to-face people. And N should be the total number of students.
Underneath that P, what does it say?
F2F, an abbreviation for face-to-face.
Do we have to write F2F, or is that something?
No, that is something I just added to normally you wouldn't write it. Let me cross it off. That might make it easier. You don't need the F2F there. I think I got it all confusing there. My bad.
Oh, you don't need it?
You don't need it, no. That is just more to help me figure out what I'm gonna use for my X and my N. So do we have those numbers?
Yes.
What are they?
Number of students is the online and face-to-face, just add those up.
That's right. So they didn't actually give us N, but we can calculate N.
Yeah.
N is gonna be 389 plus 791. N should be 1,180.
Yeah.
What's X?
The 389.
389. All right, that's what we're gonna enter into StatCrunch. I'm gonna set up my 5 steps of hypothesis testing. We extracted the important information we needed out of this sentence. Other than when we state the conclusion, I'm just gonna go up and jack that shit. Step 1, I actually wrote it already. H naught is P equals 0.40. HA is P is less than 0.40. Step 2 was identify alpha. None was given. So we will go with the default. Alpha equals 0.05. Step 3 is calculate the test statistic and p-value. And we're gonna have to go to StatCrunch for that.
What's the 8?
What?
Calculate the statistic 8 p-value?
And,
Oh,
the ampersand. That does look like an 8, my bad. I'm like, what the fuck, 8? What are you talking about? There's not an 8 up there.
and my eyesight as
How
well.
about I just get rid of the word, that bucket symbol, and write the word and? How about we do that? All right, you guys ready to do it in StatCrunch? Are you fucking drawing Donald Duck, or you write shit down?
Right.
All right, we're gonna wait on John Lucas, it's all good. We're almost done.
Step 3 is we go into StatCrunch, correct?
Yeah, this is a StatCrunch thing. So we're gonna go in StatCrunch. I'm gonna go stats, proportion stats, one sample. And I do not have a list of values or answers, so with summary. If you have a list of everyone's responses, you do not need X and N. The computer will look at your column of answers and go, all right, what's good? They just need to know what in that column means success. He immediately picks up his phone like we ain't fucking sitting here waiting on his ass. What a jackass. Put that, you don't get no fucking phone break in here, John Luca. All right, we're gonna go stats, proportion stats, one sample with summary. We had 389 people. That's right, X was 389. My number of observations was
180.
1,180. H naught, this is where what we wrote for H naught and HA goes right here in this box. So what you have to change is this value right here. As soon as I change that to 0.40, notice how it fills in HA to 0.40. So you change that value there, and you just need to make sure you put the HA symbol in. There's only 3 choices. We had less than. So you gotta enter the, I'll write this down when we get back to the camera. That's it, compute. The Z-stat is the test statistic. P-value is there. So I'm gonna write those down right now. But y'all see where they're at, so I can just go over the camera and, okay.
The Z-stat, the Z-score, or
It's probably is. It's probably why it's called Z. We'll look at it in a second. We can. We'll look at it. All right, so Z-stat was negative 4.93. I think that's the Z-score. It feels about right with the p-value being this low. And the p-value was less than 0.00001. 3 zeros and a 1.
Z-stat or Z-score?
Z-stat, that's what it says. All right, so step 4, compare alpha and p-value. My p-value is we'll just say 0.0001. It's actually less than that, and alpha was 0.05. Which one's lower?
P-val.
P-val. 0.0001 is less than 0.005 or 0.05. I strongly recommend you write down what that means without doing the sentence first. The p-val's too low, reject the hoe. Reject the hoe goes with support HA. Step 5 is the statement of conclusion. Remember, 5 is about HA. It's about HA. So when we do our statement of conclusion, we're supporting it. There is sufficient evidence to support the claim. And check this out. I'm going to just come up here and steal the shit out of this sentence. I guess I got to do it side by side. The claim was that less than 40% of students want face-to-face Math 21 stat classes. I'm just going to drop that shit in right here. That less than 40% of students want face-to-face Math 21 stat classes. And if I want to add in the optional part about the level of significance, I can say at the 0.05 level of significance. You don't need the word the, at 0.05 level of significance. And the only reason I wrote the red is exactly what I hijacked from up here. I literally just copied it word for word. Usually you can do that. Usually the way the question's worded, it's set up for plagiarizing. I'm gonna check something real quick. I'm getting a different one. Okay, that's the hypothesis test. That's all it is. All of the ones in the homework assignment, like when you start doing them, they'll do this. They might prompt you for some other shit. They might ask you to find mu. They might ask you to find sigma. That's just doing these formulas right here. Okay. Use the P that's from the sample. The sample is 389 over 1180. So mu here, mu of P hat is the 389 over 1180. It's not the H naught P value. Or not the H naught P equals. Tomorrow we'll do start 10.3, which is on doing one sample means. And then we'll do chapter 11, which is on the two sample stuff. And I'll actually, tomorrow, when we've got more time, I'll show you how it ties into the confidence intervals, and you'll see how they're connected. Because you saw on StatCrunch, it's clearly connected, or they wouldn't you wouldn't offer it in the same fucking window. There is a connection there. What is it? We'll talk about that more tomorrow. It's been fucking 3.5 hours already today. I think I've tortured you enough. Although you've redeemed yourself. You're eating Cheez-Its. This is good. Cheez-Its are fucking baked cheesy goodness. They're fucking fantastic. One of the tastiest crackers on the planet. All right, that's it. You are free to go. If you want to work here, you can.